Hi.
Hi.
Just short announce for all our chats. Seems community already forgot that we have some community meetings.
That's what you get for canceling them.
Yeah, I was thinking about how often should we create community meetings, because when they was every week, there were also not so many people. When we switched to bi-weekly meetings, there were more people, and 4 weeks probably doesn't work. Okay, let's wait for a few more minutes. We can start with our Cozy team. I like this approach because I was in KubeVirt community meetings, and they always have all the team of developers there. So it is not important if the community joined or not. They always solving some questions regarding the project on those meetings. They get recorded, and community can see them later in the recording. So I think we can adopt the same approach. All right, I'm going to share my screen and put the link to this chat, to this document into chat. Please fill your name in this document and we can start. So welcome everyone in our bi-weekly community meetings. Today I'm going to introduce the new Cozystack version. So there were big job done for implementing new dashboard, and finally it is in main, and we have first release released with the new dashboard. There were also some other changes. The main change is a new dashboard. We implemented new dashboard, which can be configured with simple custom resources. And we also extended the Cozystack API and Cozystack controller to automatically create resources in dashboard. That's a next step before Cozystack decomposition. So for now, for defining new applications, you just need to create specific Cozystack resource definition, which was extended. Now in this Cozystack resource definitions, you can specify many fields, how it should be, how this application should be shown in a dashboard. We don't dedicate on we don't depend on old approach when all the applications should be defined in HTTP server running inside of the Cozystack. Now we also start supporting external repositories, which can be configured as simple Git repositories. So now dashboard works purely with our own API, and this API depends only on Helm releases. Those Helm releases can be installed both from Helm repository or from Git repository as well. The next step would be to solve few issues with role-based access control. And I think we are done with this epic. Also, there were many changes. We implemented lineage webhook. Thanks, Timofey, for the implementation. So all the resources created in user applications, they will be properly marked with the specific labels. And those labels also used by the dashboard to show all the things inside of the deployed applications. What else? Yeah, we fixed few issues with labels, monitoring labels. Also introduced CSI resizer for KubeVirt and snapshot support. And there were some changes for Velero. We properly tested workflow for making backups of management Kubernetes cluster. Now Velero updated to the latest version, and it includes data mover. There is documentation for this. You can find it in the documentation page. Backups. Now Velero includes data mover that works the following way. So before you need to create a backup of every persistent volume claim, it will create snapshot of this volume, and then data mover will send this data to the S3 storage and automatically deduplicate it. There is also flow for recovering snapshots tested. You can restore, since Velero makes backups of resources and also data, you need to properly restore them. So first you restore persistent volumes, and then you restore the rest resources like secrets, config maps, secrets, and data volumes. And then you can restore Helm releases. So we properly tested this flow. Now it is possible to make backup of user applications and restore it. That was primarily tested for virtual machines. I think that's a next step which we need to have before we implement a proper backup API for the users. Now let me show you dashboards. We have dev 5. I need to put my nickname here. So the new dashboard includes cluster selector. In the future, the same dashboard will be used for multi-cluster mode, but for now, the only single cluster is supported. So every cluster runs its own dashboard. This dashboard includes the default cluster. You need to click on it. You'll see all the namespaces where you have access. This is also done by Kubernetes API layer, aggregation layer resource, which is called tenant namespace. Inside of this tenant namespace, you have the marketplace for deploying the applications, and now you can simply define your own applications here. The existing applications are split to 3 different groups like IaaS, PaaS, and NAS. In the future releases, we will make them optional, so it will be possible to have just specific groups deployed in your Cozystack cluster. So you can opt out the PaaS layer and NAS services, for example, and keep only IaaS. Many people expecting us for having this option. Every resource page includes a table of resources. And every resource page includes the information, basic information about resources as well, flag CD conditions. Also, it includes workloads. In workloads, you can see what exactly workloads are running there. Nothing go wrong? Okay, we will check that. Also, ingresses, services, secrets. and YAML definition for the resource. This dashboard also includes the configurator for the resources. Now there is no comments which we had in YAML, but you can see them directly from OpenAPI spec. This dashboard, this form created automatically from Kubernetes OpenAPI spec. So when you're creating new applications, those applications should have a proper specification specified. And this specification is generated from Helm charts using our Cozy values gen generator. The dashboard supports adding new resources. You can add some fields here. They will automatically appear in this YAML spec. So that's pretty much it. Yeah, tenant modules moved to specific administration area. Here you can create new subtenants. The same, you can deploy some specific applications for this. Those are called tenant modules. Yeah, and my user currently have no access to create new tenants. This is not allowed here, but it would create new tenants, and inside of this tenant, it will deploy modules. For example, my tenant have a CVDFS module, which has the same approach with workloads, ingresses, services, and secrets. The next steps would be to add VNC console for the virtual machine. It will appear here as additional tab. Currently there are no VNC component for this, but we are working on this. And I think some of other resources, they will have specific fields defined or specific tabs. For example, for virtual machines, you would see KubeVirt virtual machines for accessing them. All right, then the next topic is CozySummit news. We finally reviewed the schedule. The schedule for new Cozystack Summit is ready. You can get free tickets. Please register on CozySummit to not get lost this event. You can see agenda here. We accepted about 6 or even 8 talks. Please stay tuned and register on this event. It will be on 3rd December.
On where?
It is a virtual event, so it will be, I think, on YouTube or some other platform. I guess you'll get the link where it will be proven, and you'll see it on your calendar as well. All you need just to register on it. And now we have few topics to discuss. Right now we are working on implementation for VPCs. We have Nikita here who is working on this, and we would like to talk about that a little bit. Is there anything which we can share, Nikita?
Yeah, I can show a couple of pictures. Just really 2 of them. Let me share my screen. Can you give me rights to share my screen?
Yeah, I just need to stop sharing my screen. Got it. Try it now.
Yep. So you see it.
Yeah, I see myself.
And now, can you see?
And now we see your screen and presentation.
Okay, great. So basically, how VPCs work now are shown in this picture. So basically, we have a single VPC and a single subnet for every tenant, basically for the whole cluster. And every pod is just plugged in this subnet and has an IP address from here. So the idea of VPCs currently is like that. So here is the basic VPC, and here are additional VPCs. I just show a couple of connections because it became too messy. So each workload would be able to connect to default VPC and to dedicated VPC, which would be attached to a tenant. And you can see two connections. For now, we will need management or default subnet to be connected because we don't have external connectivity on subnets for now, or even some service things like DNS or gateways. But you will be able to connect, for example, some root applications from root to your pods through this, minimizing connections to management or default network, and these functions for networks which are in your separate VPCs will be expanding. So that's it. Maybe I could answer questions if there are any.
How can we secure other tenants for connecting any random subnets and VPCs of other tenants?
So each VPC would be attached to a tenant by its spec. It has a namespace field in it. And if it is attached to a namespace, different namespaces could not use it.
Okay. So what is the phase one? I guess the first implementation, it will not be allowed to multiple tenants use the same VPCs, or is it?
No, a single tenant will use multiple VPCs if it wants, but other tenants will not be able to. So a VPC could not be shared with different tenants.
Got it. Is it possible to add this functionality later? I guess yes.
Yep. Yes. There are also VPC peerings and stuff if we need some connectivity or fine-tune the connectivity.
Yeah, that makes sense to not have the single VPC between the multiple tenants, but set up VPC peering between them.
Mm-hmm.
Thank
I
you.
think that's it about VPCs. If there are no questions, I think we can go.
All right. The next topic is backups overview. I already shared the document which describes how to create and restore from backups. It uses Velera as a main tool for backing up the Kubernetes itself. We have a task to enable backup for all the applications. And I was thinking about what the proper way for doing this. I think it might actually the problem that all the applications have their own backup logic. For example, if it's Postgres, it uses one logic, and if it's virtual machines, it uses another logic. I was thinking about creating some common API or at least some practice for defining those backup schedules, or how can we actually create it? For now, some applications already have some options for configuring backup, and you can configure backup directly in their specification. What if we will have this as cross-link to some specific backup locations? So we can introduce specific resource where users specify backup location once, and then just select it from the application specification here. Or we can go from the other, and we can create one resource for backup and use some kind of label selectors to send backups to the backup location. Any ideas how it would be better?
Well, it would be nice if backup was basically a field at the top level of the application, just like a spec, and say it would have a single schema for all applications. You just specify the backup for the application. I don't know, like it's here, maybe with an S3 path, and then somehow that is taken care of. No, I'm really not sure. I mean, you have to, every application has to be backed up in a different way. It would be really nice to have one single unified interface for that, but I'm just not sure how feasible it is.
I think we can decompose some specific fields like destination path, endpoint, S3 key, and access key and secret key into a single resource and somehow refer it for the application. Maybe to add some opportunity to override fields from it. Let's say schedule can be different for different applications.
I don't know, maybe if we on the Cozystack side could design an interface for backups, and then application builders will just have to satisfy that interface. Maybe that would be a nice approach. The way, like one of the proposals that was by Kirill was that if you have the backup field defined in your application, then that both defines where the application backs itself up and how it restores itself if you're restored from a backup.
Yeah, you mean this recovery time and old name field?
In a way, yeah.
In Bootstrap, I guess it will take specific backup and recovery time from it, and it will recover itself from the settings specified here. I'm just thinking that we can move those settings from the spec of the applications into specific resource. It could be visible here in administration or backup management. So user wants specify all the settings for accessing their S3 storage for backups. And here in applications, they can actually just use it the same way like storage class here. They can have backup class.
Something like that, yeah.
I have some ideas, if you let to say. So if we have existing application, we can create the tab of backups and create some resources for backup of it. So it will be split or no, different for other resources and specific for other resources. For example, we can create, for example, MySQL, and after creating, we can configure the backup functionalities, and after it, it will step by step. So we created resources, and after it, we configure of backups.
Yeah, you mean to adding new tabs about new tab here. I think we can.
Yeah. And after it, we can create the tab of restore histories.
That makes sense. So we can, I think the best option would be to have additional option here in sidebar with backups. It can have 3 separate resources: backup schedule or backup class, created backups. So after any application is having new backup, it will be listed and possible to restore from here. We can write simple wrapper from Velera resources into tenant resources. And this table can include information about what the application was backed up and which data it includes inside. Yeah, and restore button makes sense. Or we actually don't need to have restore button. We can just add new resource, let's say Postgres, and just specify if it should be recovered from the specific backup listed as this resource. I like this idea.
Yeah, it can also apply to tenant for Velera. So we can create backup resources for Velera and backup or restore Velera namespace from other. So we can duplicate of existed tenant for creating some other tenant.
Yeah, I would schedule this to phase 2 or even 3. For now, we just need to have the backup functionality enabled. Yeah, we have phase 0. We have opportunity to create backups, but we have no API. So the next step is to implement API resources and the logic behind that. And step 3 is to create big backups of everything what exists in the tenant. All right, then, any other thoughts on this?
Yeah, I really like the idea of a storage target for backups. Just
what do you mean by this?
So you just pre-configure some S3 bucket or something, or a subdirectory inside the bucket, and you specify it as you showed, like similar to storage class.
All right. Thank you.
Without those API keys and S3 paths and so on.
Yeah, I think those secrets should not be stored in every particular resource which needs to be backed up. All right, the next topic is dedicated API server for external components. Probably, Timothy, could you introduce this topic?
Sure. Yeah. Since we introduced the new dashboard, we had a lot more custom resources appear in our API group. Directly, perhaps, I don't know, share some tenant secrets in the dashboard or tenant secret tables just to demonstrate what's going on. And yeah, so indeed, we've got, well, some resources like the CozystackResourceDefinitions. They're a bit simpler because they're normal Kubernetes custom resources, and some other things such as tenant secrets, tenant secret tables. They right now are also being served by the Cozystack API server as special representations of resources actually existing in etcd, such as like the regular secrets, just a special representation. So what I'm thinking is now when the Cozystack API is expanding with more and more like core or system resources, perhaps the applications which right now live in the apps Cozystack.io API group, perhaps they're the ones that are not in their place. And especially since we're taking the direction into decomposing Cozystack and making applications pluggable things that you can enable or disable, like Andrei said towards the start of the meeting. Like maybe you don't need all the Postgres and MySQLs and whatnot. Maybe you just need virtual machines and manage Kubernetes. So what I'm thinking the steps for the future are is that the applications, the managed applications, at some point in the future, they should no longer be served by the main Cozystack API server, but we should have an additional API server for these pluggable components. And perhaps even deploy new additional API servers for third-party applications, for third-party API groups of other application developers.
I was thinking of, do we really need to have separate IP server for them? Can it be the same API server running in Cozystack? Because it probably dependency for the dashboard and for the API contracts we're having right now. Is there any reason for having this API servers separated, or just having separate API group for such resources?
Well, we already have a separate API group for such resources.
No, I mean to split apps.cozystack.io to have repository name .cozystack.io or something like that, or define completely new groups, but serve them by the same core API server.
Well, I don't know. Yes and no. There's ups and downs to both approaches. On the one hand, right now we have this rather monolithic thing where you need everything in place at the same time. So I don't know if the dashboard, for example, is the dashboard aware how to reload the API, the open API schema when it changes, or what happens when you deploy a new Cozystack resource definition.
Yeah, it is totally dynamic. When you create new Cozystack resource definition, we have Cozystack controller, which configures dashboard with its own custom resources. So it creates sidebars and custom form, overrides, prefills, and all of these things.
Well, yeah, in that case, yeah, you're right, because the dashboard is just a front-end client which makes the right API calls to Kubernetes. If something changes, Kubernetes will serve the new things. Well, in that case, I see no problem either way of having a separate API server for a separate API group, or having them all together. You know, it's more of a matter. Like right now, we have the Cozystack controller restart and the API server, something in the custom resource definitions changes. So I don't know, what do you prefer to restart the entire extension API, or restart just the one API group? I think both approaches are fine.
I think we need to teach how to learn how to restart, how to reload Cozystack API server without restarting. And what is more interested, how to enable dynamic registration of API versions of API groups. This can be done by Cozystack resource definition, where we can specify specific API group for every particular resource added by user. We can, for those resources, we can automatically create API service resource in Kubernetes. So it will point to specific API server, which will serve the requests for that. Actually, I'm not sure if we really need to have separated API servers, because we're still having the same flux, which is used by all the applications created in Cozystack. So I think it can be, and API server we're having right now is just proxy resource for which proxies requests to this Flux ID. So we can just create new API services. I can show that in my console to make it more understandable.
Having no, I mean, I also was open to the idea of having all extension API groups on the same API server. I just think that at the moment, it might be somewhat easier, to use the Helm chart approach and just create copies of the API server, but with different API groups. So you have a Helm chart for the Cozystack API. You just make the app Cozystack IO string a parameter for that Helm chart, and then you can deploy as many API groups as you want.
Yeah, that's possible. We also have to think about OpenAPI spec because sometimes it can be broken, and this will affect all the cluster. I don't want. I want to have it under control. So do not expose broken API, OpenAPI spec. I think it can be handled by the API server code as well.
Yeah, that's an interesting thought. It would be actually quite cool to implement on the API server side some sort of internal validation. So if internally it detects a broken open API schema, then it just falls back to some sort of default minimal schema, so that when so that when Kubernetes discovers the extension APIs, it does not break everything for everyone. Like not so long ago, we found, I think with the billing modules and so whatnot.
Yeah, one more thing is versioning. What if we will map Helm chart version into API group version?
That would be wild.
Maybe we could have some kind of a CRD which describes external resource, and it could have a version or something.
Yeah, the question is more about the using Kubernetes API groups dynamically generated from Helm charts. That means that for every application, we can have various groups, like not only v1, alpha1, but it can have on all the chart versions actually defined here. Maybe this is a bad idea.
This would explode your open API schema.
And that's true.
Yeah, the problem right now, to be quite honest, is that all of our managed applications, well, up until the point that we deprecated versions map, all of the managed applications, in fact, had they were all in the major version 0, absolutely every one of them. And we were breaking API compatibility left, right, and center. While it was, still a Helm version before you introduce the open API schema for the spec of the application, that was just fine because we were able to maintain a reference to the Helm chart version. As soon as we introduced an open API schema, we were screwed because what you're going to have 15 versions of essentially 15 major versions to maintain at the same time. That's untenable. And another thing you have to keep in mind, usually when your extension API server is serving multiple versions of an API, you've got generated code which converts your resources between the multiple versions. But because these applications are injected dynamically, you don't have that possibility anymore.
I think of having some specific DSL which will convert old versions of spec into the new one with backward compatibility. For example, if you had field on the top level, on the next spec, you have it under some additional map, you could have some DSL which will say that this field moved here. And users could keep working with the old spec and with the new one. I was pretty surprised that in Kubernetes, there's nothing like that. There are some conversion webhooks, isn't that?
Yes, there is a concept called conversion webhooks. I think the Cube Builder book goes into detail on that. This was actually in my mind for the past few days now. I just thought it's a bit premature. And in fact, I still think it's premature. I really think that this would be something worth talking about once we commit to some form of API stability.
Yeah. Well, that's a nice discussion. Let's switch to the next topic. We have 15 minutes left and so many things to discuss. The next topic is dedicated security API server backed by keycloak. I guess this topic is from Nikita.
No, that's from Ivan.
Yep.
Could you please introduce it?
Yep. The main idea is the cut of security functionalities from Kubernetes and Cozystack API to other API server, which allow and provides communicate with keycloak and Kubernetes, etc., for creating external, internal API API security keys for communication between our security groups and our applications. For example, the tenant have static link to Kubernetes resources, and it deborn some problems and some security issues for authorization. No, now we have some errors with the tenant name, which allow super administrator abilities. So we can create other API server which provide security functionalities, some error bug, etc., for it.
Yeah, I think we're having right now, and we don't use API server approach here. We use controller approach from EPAM. They have operator for operating keycloak resources. We can consider adding new entity like user management in Cozystack dashboard to hide the keycloak UI from it. I think that might work. So the same thing, we can just create additional entity here in administration, which will, I think it would work in cluster level here to let users to create new users here. And this functionality should be pluggable because some users use OEDC external servers, let's say from GitHub, GitLab, and Google, to automatically authenticate users from that.
Yep, and after it, we can create some functionalities for configuring security roles, security groups inside the tenant. So we can create the user, which can create Postgres on virtual machine, but not Kubernetes or some other resources.
That thing you mean. Got it. Well, that's a quite good topic, as I think we can start with writing full design for this. Actually,
Andrei,
yeah,
take your hand off your
yeah.
temple.
Sorry, always forgot about that. The idea is nice. I would start with phase one is to create users and group management in Cozystack UI. But this is not very critical task for now, I think. Or is there anyone on call? I think there are not many people here right now who really needed it right now. All right. So maybe someone from the community will be interested in designing this. Let's switch to the next topic is status page and SLA dashboard implementation. Who put it here? Could you please introduce it?
I think Ivan brought this subject up as well at one of our dailies.
Yep. So the main ideas is include status page in our new dashboard, which allow to show status of our applications, aggregated application status, and status of the Cozystack actually.
I think this is done already. We have a resource, how's it called? Workload monitors entity, which is dedicated on exactly to this. So for all the for the deployed applications, you can see workloads page, which shows it shows just replicas and min replicas and how many of them are available. There were also another field which shows if it's currently operational or not, but it is not shown for some reason here. Yeah, we can actually create a page for showing all the workload monitors in a tenant namespace. And that would mean that you can see all the workloads if they're running or if they have any problems running there. But I would probably wait until we implement process into the dashboard to take this information directly from metric storage. Or we can also consider implementation for additional API server for showing these stats. That's more about what exactly metrics which exactly metrics we want to show here, because SLA dashboard usually means it's not current state, but how much or what the SLA number is, how many nines we have for every service running, and that might be useful.
Yeah, it also about the Cozystack. If you have some problems with Cozystack, for example, some problems with the Flux or KubeVirt, we can the first show on this page on the dashboard, and now we have some data about our system. So if you have some internal problem, we can see it. Not only for application inside the Cozystack.
I think this can be done by implementing alert interface into Kubernetes resources and show it in dashboard.
Yeah, for example, we can create we can put the link to monitoring or alerting for faster switching to alerting page.
No, I mean that we can take alerts and just show them in the dashboard. So I would like in the future releases to have everything in a single interface, to not having separate alert stuff and Grafana stuff. So I think it can be shown here as well. That's an interesting thought. Let's postpone it for the future. So many things to implement. Best way to implement dropdowns for Cozystack resource definitions. That was my topic. For now, we have Cozystack resource definition for every application, and we have specific services tab and secrets tab, as well the other tabs. I think we need to add this logic for if this application have no specific tab specified here. Let's say this one is Postgres, it have no ingresses, so we can do not show them in dashboard because it will always show it as empty page. For example, Postgres, ingresses are empty here. That's a first thing.
Is the factory for Postgres generated somehow, or is it?
Yeah, the code for dashboard is generated by controller. And I'm pretty surprised that there were some error.
Andrei, by the way, what version do you have running here? Oh, 37.1.
Yeah.
Okay.
I think it might have some bugs or some dev code deployed here. I'll check that after the call. So in fact,
I'm just wondering if you have Foundation DB somewhere in there.
no, I don't have it. And we need to define specific fields for the dashboard. For example, to let when you're creating virtual machines, we want to provide the opportunity to user specify instance profiles and instance types as a dropdowns. Those fields can be defined here in Cozystack resource definition as additional field in dashboard. That's a second thing. We need to move key order in under forms creator or something like that, and just introduce another parameter which would allow you to specify that this field can fetch resources from cluster instance types of KubeVirt resources. In that way, it might work. Because the dashboard itself already supports these dropdowns to define, which can be fetched from another Kubernetes resources. You just need to specify curl which you need to download to show this table map.
Andrei, do you think how should I put it? We generate a lot of the dashboard related stuff from Cozystack resource definitions, right?
Yep.
Would it be possible to have a custom resource that overrides whatever was generated from these Cozystack resource definitions? So, like, look, an application developer can say, for the example of Foundation DB, say the developer that added Foundation DB. By the way, a huge thanks to Insignia96. Don't know the real name, but I'll mention him again at the end. So, say the developer of this new managed application in Cozystack knows that he has a spec, I don't know, instance types field, which should select instance types. So with this application, he bundles in some kind of custom resource, such as API fields override whatever that specifies that, okay, for the spec instance types, make this field a dropdown.
I really like this idea, and I know the working implementation for this is Piraeus operator, which allows you to apply customized patches to the resources. So we can say to the users that you can use, that you can override any field of generated resource and specify it that way. Actually, customize allows you to specify specific fields. I only think that it might be slightly difficult to do for really huge resources like factories, let's say. But we can try. That's a thing. We can try to implement it that way. From the other perspective, why not just simply extend Cozystack resource definition? I think for specific things like for showing these dropdowns or defining tabs, it can have common fields and also this opportunity to override.
I don't like the
Yeah,
idea of overbloating Cozystack resource definitions with functionality for everything, starting from the Helm chart, then the keys in the dashboard, then you have like very dashboard specific code. I don't know, maybe if if you split things up into pieces, it will lower the entry bar for third-party application developers to contribute. If they just want to give you a new app, okay, they've got the Cozystack resource definition that they have right now. If they want to go a bit beyond that, then they can add some configuration files for the dashboard.
One more question. How do you see that API? Is it should be part of Cozystack resource definitions, which defines patches which have to be applied, or it should be different resource?
That's what I'm saying. I think it should be a different resource because the Cozystack resource definitions are grown without any bounds. This is how we ended up with the gateway API in Kubernetes. It's a widely regarded belief that services are one of the worst APIs that there is in Kubernetes. It really goes against the single responsibility principle of in Linux.
Yeah, and I understand this. One more thing that might be pros for implementing this as Cozystack resource definition, that we can add tests for test this functionality, and sometimes we can update it. Let's say in dashboard we have this field which generates colorful page for every resource, and for now it's just I would say just span like simple HTTP code, HTML code, sorry. But starting from the next release, we will have a page, and we can just keep this logic updated in our controller. If we would say, user, if you want to specify these resources to show it like that way, we will have a lot of different things for everything. I'm not sure if you understand what I'm talking about.
This is something out of the world of front end. Yeah, I'm not sure.
No, I mean that sometimes it might be better to take some string from the user, what they want to show here. Okay, we can show virtual machine with specific tabs. And in the future, if we will change the API, like backing API for dashboard, we will know how to update it properly. But user would need to update all of their patches to show it that correctly. So I think some common things can be specified in our API just for this reason. But still, I think it's a good point to have this kind of customization to let users specify any additional things here with the patches. Also, we need to think about how to properly specify parameters to show from the spec. But that's the next topic to talking about. For now, time is up, and we didn't switch to OpenFloor yet. So we will move it to the next meeting. Sorry for that. So many topics to discuss, but that was nice discussion. Thank you everyone for participating, and see you in 2 weeks.
Thanks, Andrei.
Thank you. Bye-bye.
Bye-bye.
Thank you. Bye-bye.
Have a nice evening, guys.
Thanks, everyone. Have a good night.